Hello, my name is Viva Cunliffe. I'm an applied scientist and I work in the environmental field, developing helpful technology for the environment. I would just like to give a brief overview of the compounds in the atmosphere that are of some concern to a number of atmospheric chemists of great accomplishment. They're called the hydrooxygens. And in plain language, that means that they're the water oxygens. And there's a whole group of them, and they are combinations of hydrogen and oxygen in just about any way you could play with them on a sheet of paper, up to 2 oxygens. And they are infinitely soluble in water, so this is why they're called the water oxygens. This layer is called the oxidative layer, and I would liken it to the immune system of our planetary climate system, because these atoms and molecules recycle themselves, interact and then decouple from particles and go on to cleanse again. And the planetary system has been set up so that we can actually burn and combust, such as in natural events like forest fires, volcanic eruptions. These are actually accounted for in our natural system. And the other reason that they're called hydrooxygens is simply that the water, which is the circulatory system of the atmosphere, it travels at about 40 miles an hour, average traveling speed around the globe. So we have a global circulation system that takes about 2 weeks for particles to get distributed globally around the globe. So I'll just move on to the next illustration, and we'll talk a little bit about cloud charge. So it's very, very elementary. The positive charge builds up at the top. Gradually over time, as the cloud moves through the atmosphere, it picks up friction, and there's a negative charge that stands below the cloud. And at some point, the positive is the electron distribution affects the cloud, and it will discharge water and sometimes lightning. So you get your excess discharge that way. This is essentially what a normal cumulus cloud looks like, and it's really very simple on a large scale. Next, what you want to look at is the consideration of regional charges. These systems meet each other and interact with each other. So over here, we might have one that comes from a city, and it's got a lot of pollution in it, so it brings with it most of the time a lot of positive charge. So what happens if this is a nice clean oceanic cloud, and this is a city system that's been pulsed full of mostly positively charged materials, which are not necessarily all that bad, because if the immune system is working full tilt, these things are mediated as this travels through the atmosphere by the oxidative layer. So when they meet, however, there is going to be a charge difference. So this one would be negative to positive. So there has been some work done on sudden inclement weather forcing, and the concept that when a clean front meets a polluted front, this can cause a dramatic increase in rainout and very sudden discharges of energy in the form of water and also in the form of electricity. So there's a third one now that we have, which is being introduced, which is a geoengineered cloud, or a cloud that's been injected or treated with oxides of the alkali earth metals. So this one now is going to be a negatively charged, very negatively charged cloud, and it will try to have the same thing occurring here. It's a bit unnatural for it because you can see that the negative polarity goes up higher into the cloud, which is now dispersing hydroxide ions in conjunction with alkali earth metals. So this one is a new wild card that's been introduced into our system. It's probably being done with good intentions, but I think the net effect now, after 20 years or so of this activity, it's time to stop and do a control and prove out whether or not this actually did impact for the desired results that we were looking for. In this overview, what I have to say about this particular type of system coming in is it multiplies the chaos factor by at least 50%. So right there, just mathematically juggling 3 issues rather than 2 is quite a substantial situation to create. Also, if this cloud system meets with one of these, you get a great difference in the systems and far more dramatic discharges. I would suggest that this is where we get our massive unpredicted flooding, because ultimately we can't always control where the cloud systems are going to evolve and then transfer over into another region. And so this line up here actually is the para-regional or cross-regional area where we start to lose control of anything we were trying to do here. And I submit that if we have a good oxidative layer, which is currently depleted by 30%, exactly almost the same amount as the ozone layer, that we can control that at ground by modulating our emissions and also looking at a remediation. But currently from the para-regional and above, we have difficulty in influencing that, even though these discharges are occurring above the cloud and around the cloud at about 40,000 or equivalent above the atmosphere. 40 to 60,000 feet. Above that, you have your jet stream, you have the solar conditions, you have oceanic currents. These are factors that we cannot control. So essentially what we're doing is we're adding chaos potential into a mid-layer that we can essentially, at our stage of development and scientific ability, we can lift and intervene at this level, and apparently we can afford to do it. I don't think we can afford to let this experiment continue at this point. I think there needs to be a decision tree whereby the 20 years or whatever the years are that the spraying have occurred now needs to be discontinued, and there should be a period where this activity is removed and halted so that we can eradicate that chaotic factor that was brought in, which is at least 50%. And then I do think that developed society is actually managing the pulse issue very well by adding all of the clean and green energy that we are developing. So this issue in here of the differences will be steered back to a natural, sustainable type of system. The other thing we can do is the third factor in there seems to be leaving behind a white haze in the environment, and this is really some kind of aerosol particle. And aerosol particles in atmospheric chemistry are generally classified as simply the kind of particle that the clouds cannot normally scrub. And when I say scrub, I mean they absorb it into the cloud, they form nuclei, and then they rain it out. So the next thing I want to briefly go over is nucleation. Okay, it's not a really well understood area from the reading and the original papers that I brought in for my research, but basically you have a particle and you have negatively charged ions like a hydroxyl. The particle, we will just say, is inside of a cloud, and the cloud is quite a thin cloud, but it's going to start nucleating. So what happens is the particulate, which may be pollution, tendency of that particle to be on the positive side in this relationship is high. So what you have in here is an attraction. So once you start having enough particulate and cloud condensation nuclei, you can pick which one you actually want to consider the instigator. The point is that they attract in the middle. There is an attraction. So that's how you get a nucleus. And then once you have a nucleus start to build, and the charges are balancing and going positive and negative in sort of a pulsing type of way, more will participate in very brief periods of time, like, you know, thousandths of a second. So you'll get more particles jumping in, and then more hydroxyl or other hydroxygens going in. So you end up with more of a solid particle, and it's moist. So you have basically the net effect is water that has dirt in it that rains out. So that's a very simple lay understanding for you about nucleation inside of a cloud. The temperatures are very cold, and this is difficult to replicate at ground, but I do know that the hydroxygens have a very low freezing point compared to water. In light amounts or small amounts, they don't start freezing until -2, and they can go down into -2 Celsius. They can go down 10 or 20 degrees or further below that before they actually freeze. So they can remain active inside a big cumulus cloud, creating chemical reactions and nucleations in a very dense cold cloud. So the reason that I'm giving this lay description is that I just wanted to draw attention to the alkali earth metal treatment, and the fact that it essentially artificially delivers hydroxide, which is not the radical, it is an ion, and it's over here with, say, a calcium or a barium or something, and these are positively charged, and they will tend to want to stay in ionic balance with each other. So what it does is, instead of having a cyclability and freedom of movement, this hydroxygen, which has been artificially introduced, hijacks the chemical reactivity of the cloud in a very simplistic way, and these salts then are by themselves, if you look at the material safety data sheets for them, both as oxide, calcium oxide or barium oxide, they do have a significant number of safety and handling procedures, both by themselves and in conjunction with oxygen. So they're very serious compounds to be introducing, and the good intention over here actually causes the inhibition of the circulation of water. That's what it's doing. So it's actually hijacking the cloud chemistry and the cloud physics. So what I'm calling for here is to stop this introduction of this type of manipulation of particulates, and have a control period where we can evaluate and know whether or not it created a positive difference, because the fact that these are aerosol type particles that leave the white haze I mentioned earlier, what's happening is the atmospheric venting at nighttime of heat is being inhibited by the aerosols. That's already a known fact. So if these are being introduced artificially, we need to call for the stopping of this activity. And if worst came to worst, this oxidative layer, or the immune system, which is missing by 30%, if we need to, we can remediate it through a couple of very simple avenues, because it's basically based on negative ions of oxygen. So it can be another option if we have to, if something in the control period indicates to us that we haven't stopped sudden inclement weather forcing, and we haven't stopped some of the unpredictable climate changes, which I think we would actually substantially achieve if we stop doing this, then we can evaluate for a remediation. And that kind of remediation, it would be very simple to just do it at ground where it can be controlled. And it's harmless to human and biological life, and it involves a very common form of oxygen. So I'm calling for everybody to have a look at this video, see the basic understanding of what's happening with the alkali earth metals being introduced, and I'd just like to thank you very much for your attention.